Alright champions, we're sort of halfway through in this thing. I've discovered a lot more stuff. Besides that, we've siliconed down those coupling caps so they're nice and secured. We've shortened their leads, we've cleaned up the lead dress wherever we can. We've done the previously stated repairs in this area and secured things a bit better. I've changed the ground scheme. I've removed the original tag strip there, which was previously grounded by that center hole. I've put a longer one on and I've not grounded it to that area, so those two bolt connections there are actually not connected to anything electronically. They're purely mechanical. I've separated, so we've got the two preamp grounds here for these two caps. I don't know why they've arranged it that way. It would make sense to have the reservoir cap and then work your way down here, but for some reason that's the reservoir cap. So that is grounded over here next to the rectifier valve, which I'll get to in a minute, and that is also the ground point for the center tap for the HT, so that's an isolated ground over there. And then this ground over here is the preamp and phase inverter ground, and that ground's over in this area near the preamp, so that should reduce the residual hum level. And that also frees up that screw there, so I can have a dedicated ground point right next to the IEC inlet there, so it's not grounded, well, not according to wiring code. Keeping this layout with the caps here and this 30 microfarad here, which happens to be a bit shorter in length, it still allows access to this bolt and this bolt here, which are the output transformer securing bolts, and I've removed them, put a washer and a star washer underneath that to help spread the load out and have some kind of preload on the bolt. Now I sort of glossed over it in the last episode, but if you go back and have a look at the schematic, there's only a 100 ohm dropper there for the screen node, and then there's no screen grid resistors, which is probably why these two valves were changed out last time, because what happens is if you don't limit the grid current, the screen grid current, when you push this thing hard, the drop across each side of the output transformer actually sort of drops the voltage of the plates a bit lower than the screen there for a moment when you're pushing it really hard, and then the screen itself tries to become the plate and it over dissipates. And the screen grid's pretty delicate, and it melts the wires. They break their welds to the end posts, they spring out and they touch the suppressor grid, and then you've got a shorted valve which is not recoverable. So we need to limit the current to that, to those screen grids on the 6v6s. You can either change that to, I don't know, you go to 10k like the original 5C3 schematic, which was why it was 10k. You could go maybe split the difference 4.7k and just have some degree of limiting, or you could insert another resistor going off to these 1k to serve both the screen grids without affecting the next node, or you can insert like your typical Fender setup with your two 470 ohms mounted on the valve socket there, one per valve, which I think is what I'm going to do because it's going to look the most graceful and be the less pain in the ass and the safest. So the rectifier, they've tapped off another rookie area. They've tapped off the HT from pin 2 rather than pin 8. So pin 2 means all the current from the HT goes through the filament before it makes its way out pin 2, whereas pin 8 is the actual cathode. So we've got to move this connection from here to here, or you're going to keep destroying 5Y3s. And the other thing I'll do is put some backup diodes in here. They've got no tonality difference at all, but they share half the voltage drop across the 5Y3, so it's going to have a very long, easy life. And if it ever does fail for whatever reason, the diodes will kick in instead, and you'll be able to finish the gig without any worries. You'll just notice a slight increase in headroom because you won't have the voltage drop across the rectifier valve as it would normally operate. So I'll make those changes, and we'll remove all the hardware and put all the lock washers, the shake-proof washers on. I'll maybe not worry about that for all the valve sockets because there's not as much mass there and they are pretty tight. What I might do there is just put a little drop of Loctite 290 on there, which is a wicking thread locker, just a tiny little bit, just to stop them from shaking loose. If you want to remove them again, you can generally unscrew them without too much trouble if you don't put heaps on, but just a little bit of heat with a soldering iron is enough to make it let go. So we'll get stuck in all of that, and then I'll fire it up again, and we'll just do some tests on the quiescent output current and go from there, champions. So it's pretty frustrating. You've got to do all of this to an amp to make it reliable, and you know, well performing. And after all of that, it still says Little Walter on the front, not Brad's Guitar Garage. So part of me doesn't want to do this kind of work anymore. If there's fundamental issues with the construction and the understanding of electronics from the builder, I feel like they should have to address it. Don't know. It's a philosophical thing I still haven't sort of come to a conclusion about. Alright, so I just went to bend these out a little bit, give it a little bit more room between connections, and one of them snapped off, so I think that's been bent back and forwards by a previous tech, or I don't know why the builder would have done that, but yeah, now I've got to replace a fucking socket, so that's great. Patience dwindling. Oh, champion, she's back together. I've just started firing it up to do initial testing, and I was wondering why the volume doesn't cut out when I turn volume down on input 1. It was this wire being intermittent because it wasn't soldered properly. So that's the actual ground connection for the volume 1 pot. So with that intermittent joint there, the solder never made it down to that bottom wire. There was no reliable ground for volume 1 pot. It's just never ending with these things. All these boutique amps, they're just an absolute can of worms. Alright, champ, she's got the full mains now, 242 volts AC. We've got 375 from plate to cathode, and 5.2 volts on one side, 4.6 volts on the other, and that's the drop across the primary of the output transformer. So just quickly, we'll go 5.2 divided by 100 ohms, which is about 102, or 98, centered around 100 ohms. So that is 52 milliamps for the 6v6 on one side. Multiply that by 375 plate to cathode, and we're running 19.5 watts. 19.5 watts. So divided by the 12, I'll turn that off before we do damage. 12 watts for the 6v6 maximum dissipation, and we are running 162% bias. So that will absolutely burn those valves in no time. So we're going to have to dramatically increase that cathode resistor to be able to bring that dissipation down, because that's ridiculous. On the other side we had 4.6 and it was 98 ohms on that side, so that's 46.9, 47 milliamps multiplied by 375, 17.6 watts, and that's 147% of maximum dissipation. We should be running about 95 with a 5% margin at the best of times, so we're 50% higher than we should be. So those valves have a death sentence in this amplifier. Now that's partially due to the circuit. They've essentially got a Tweed Deluxe transformer with a Tweed Deluxe output stage, but we've also got a Sovtech 5Y3 in there, which isn't really a 5Y3. It's got a lot less voltage drop than the original 5E3s did, so the plate voltage across the board is probably higher than it needs to be, but we've got to trim it back via that cathode resistor value. Alrighty, so I've got a 5U4 in there now. It's brought the voltage down by about 15 volts, but that's not far enough. We're still running around 17 watts per side. So that is, what, 140%, 143.4%. So that's still way too hot. Alright, champions, we've got the 5Y3 back in there. I've got the mains lowered a little bit on the variac. We're down to about 233 volts AC as opposed to our 243 we've just got coming out of the mains today. That puts the HT bang on the 660 volts AC that is on that transformer data sheet, and that puts the heater at 6.3 volts AC. Now with the stock circuits, that is giving us 16.7 watts one side, so 139%, 15.8 watts the other side, 132%, and the plate to cathode voltage is 360 volts DC. So given ideal mains input, as the transformer says 240 volts, but they never seem to be wound for 240. They always seem to be wound for 230. So we're going to have to lift that cathode resistor value significantly to suit. I'm thinking a 300 ohmer straight away and see where we sit with that. Now, given that the plate voltage is around 360 at the moment in the ideal conditions, and then when it was plugged directly into the mains, we were getting about 375 volts DC from plate to cathode on the 6v6s. We've got a bit of room to move there, so if we knock back that dissipation dissipation by changing the cathode resistor value, that plate voltage will increase, but still within the margin for a 6v6. I mean, Fender flog them at like 430, 440 volts in a Princeton reverb, so we can move a little bit more on that. I'd rather the dissipation not be sitting at around 140%, because that's going to shorten the life of the valve significantly. It's always a bit of a seesaw with these amp designs. The vintage stuff was built when you could sort of flog valves a bit harder than you can these days, so you've got to be a little bit more conservative with the dissipation. But if you go too far, now the plate voltage goes too high and you risk arcing the valve, so there's sort of a balance to be found in the middle there. Same applies to a lot of the vintage amplifier circuits that we know and love. Alright, just changing out the cathode resistor now to calm down that dissipation. I just noticed a bunch of, I don't know what's happened here, but it's like they misfired with their soldering iron and just sat on it for ages until it melted right into the socket. I don't know what the go is there. But all this heater wiring's not real great. You can see down here, this one's got a bunch of wire just sort of wrapped around a million times, melted insulation and stuff, so I think we can clean that up too, since that is a pretty critical connection, being the connection to the heater supply on the power transformer. So now I've removed that resistor, we can see under where it was, and you can see the actual heater wire itself is just sort of tacked on there, and it just looks like a big mess, so we'll clean that up as well. Alright, so we've temporarily just put in a 330 ohm 5 watt there just to see where we're going to sit with that. We're drawing about 70 watts from the wall, but that is still at about 230 volts on the variac there, so that's going to increase somewhat when we're plugged directly into the wall. You've got to sort of bias these things to have a bit of margin in there, because you don't know exactly what voltage is going to be wherever this amp's being used in the future. So that has brought us down to 124% on one side and 120% on the others at 14.9 watts, 14.5 watts respectively. So we want to go a little bit further than that, so I think next one we'll try 360 ohm, and we'll probably have to leave it there. Alright, with the transformer wound how it is, and the mains at about 245 volts today, 470 ohms on the cathode is about where we need to be. So that's got us with 395 from plate to cathode, and per side that is 12.8 watts one side, 13 watts the other. So that's 106 and 108% respectively. So I think that's where we need to be, champions. So let's neaten that up, permanently install it, and carry on with the test. Alright, champions, so it's sounding very good, but the original 6SC7 is pretty microphonic, and they do make these valves still. Electro Harmonix makes glass versions of them, but they're about $90 a tube, so you got to question yourself, like, why are we going for this valve? Is it really that super special, or is it a gimmick? And could there be cheaper designs which sound just as good, if not better, using readily available valves that are worth like $20 each? So yeah, if we wanted to put original a 6SC7 in here as per the original circuit, you'd be looking at least $90 for one, and if we wanted to replace the other one as well, you'd be looking at $180 retail for both of those valves and the new glass version. I'm not sure whether or not the new ones have issues with microphonics, so that could be another gamble as well. You never know with these small sort of production run valves. That's why it's easier and better, and just more logical to stick with the 12AX series novels all around instead of the kitschy octals. But again, just my opinion, the octal idea is pretty cool just as a sort of concept, but if you're a working musician, I'd be going for something where you're a little bit more sure in your supply. Oh, alright, looking at the specs, we've got our 425B plus 32 volt drop across the cathode resistor that's dissipating, 2.2 watts of 470R. It's hot, but it's not so hot that you leave skin on it. You can still touch it. Screen grid node is 424 volts and 1.9 volts ripple. Normally you see this in the order of like 3, 4, maybe 500 millivolts, but that's contributing a little bit to the hum. Of course, there is some common mode rejection there, given your output valves being balanced. If your output valves are a little bit out, that will have quite a bit of hum there. and your preamp node at 35 millivolts AC, 388 volts DC. So I take these notes for myself just for the book, just to have a record of everything. And it started off just as a way to memorize, help me memorize like what sort of numbers to expect with each model. So if someone asks me, they're working on their own model or something or whatever in YouTube comments or Facebook or whatever, oh, I'm getting this much ripple. Now I know, like, is that sort of normal for the amp? Is that sort of B plus? Are those voltages sort of what I would expect? This current draw, is that what I would expect? The power consumption from the wall? Are they bullshitting about the power? So this is putting out 12 watts RMS at 1 kilohertz, and at that full power it's drawing 80 watts from the wall. Alright champions, so just a quick summary of what I did starting from the mains area. I rewired the fuse, so it comes from, you can see there, the live side of the IEC, the active side of the IEC input, goes to the fuse tip. And then from the fuse ring, it follows that brown wire, which is our wiring code for active, up to the power switch at the front. And then that follows the black and white wire to the transformer. Now the other end of the primary, that's that white wire there, just goes directly to the neutral on the IEC input. Now the earth now has a dedicated eyelet there with a spring washer and a new 4mm bolt and nylock nut, and that has no other connection other than the earth pin, which is directly, well, about as close as we can get to the IEC input. So that's the old screw that used to hold the tag board at that end. Now I've got a longer tag board in there which has two grounded, well, there's no eyelet there on the end, you can see they're just purely mechanical fixing, and that's allowed us to separate the preamp ground on those left hand two capacitors from the reservoir cap. That's that stubbier, fatter one there, which is a 30 microfarad. So now that ground for that reservoir cap comes over, goes under, that's the black wire there, snakes down here, and then that connects to this here, which is the fixing bolt for the rectifier, which is where it was before, and that's also the ground for the center tap of the HT. Now that preamp ground, now that goes across here, that's that other black wire, and it mounts to this eyelet over here, which is one of the preamp valves securing screws, as well as the ground for the cathode. So moving our way along, I installed some star washers, some lock washers to all the hardware, including the speaker jacks on the rear panel. That's actually the only grounding point for the speaker jacks through the chassis, so we had to have a positive ground there, and shake-proof washers should be standard practice to use in any amplifier. While I was working in this area, I put some oversized washers and a star washer, shake-proof washer under the nut for the output transformer securing bolts. One there and one over here. I would have liked to change these caps over so the reservoir was over this side where the action's happening, but then it would have clashed with that bolt there, which is hiding behind that shorter cap. Now you can still access that, so if the output transformer needs to be removed for any reason, we can still access it without disturbing all of this. And I use some silicone for some damping, just to glue the caps together, avoid any rattling or any unnecessary vibrations. And likewise for all the coupling caps, which were just floating around before, now they're all silicone secure to the chassis underneath. That's those two and those two down here. The smaller mass ones aren't the end of the world. They're pretty well fine. It's just these big ones with their stranded wire leads that were just floating around, so now they're all silicone to the chassis, so that's good. Wherever I could, I just cleaned up and rearranged the wiring a little bit better. I didn't go crazy. I'd love to redo the whole thing, but it's already taken way too long, this amp. It's taken the majority of, well, probably half a day to get where it is now, and in the customer's mind it just had one issue, no signal, but when you crack these things open, you find it's like a can of worms. You find all these other issues that could be improved or need resolving. So over here at the rectifier, you saw earlier where I moved one of the leads and it snapped off. I don't know. I've never had a belt and socket do that before, so I don't know if it's been moved back and forward a few times. And the time I touched it was its last, like a coat hanger. You only bend it back and forth so many times and then it snaps off. So we replaced the socket. It would have been nice not to have to do that, but as soon as we snapped off that pin there, I knew it had to be changed, so we changed that, and in the process I shortened and cleaned up the heater wiring, and put some backup diodes, installed them there as for reasons mentioned earlier. In the output stage here, we kept the 100 ohm dropper, which I would have liked to increase to like 4.7k or something, but it is what it is. It's still got a bit of slightly strange behavior as a result. We've got two 470 ohm screen grid resistors there, just to give these things a fighting chance of living for more than, you know, three weeks. And we've lowered the dissipation down to about 106 to 108%, which is right where we want to be, essentially somewhere between 95 and 105%. A little bit on the high side, but we were having pretty high mains today, so about 245 volts. Often around here it's about 238 to 242. 245 is a little bit high, but it's way better than it was. So these 6v6s will have half a chance of surviving now. And as mentioned previously, we fixed up all this. The way everything's mounted is a lot more secure and less likely to fracture leads in the future. I do have some heat shrink on that. It looks like a big fat silver lead because I use some clear heat shrink on that, just so if anything touches it, it's nothing can really attack it, but you know, it's just a force of habit, I guess. And on the front panel again, we removed all this, all the input jacks and pots, and put some shake-proof star washers in there, internal star washers. In the process, we found that the ground for the volume 1 control was intermittent because it was never properly soldered from the factory, so we sorted that out as well. Not a big fan with how everything's just floating around, just resistors up in midair and stuff, but you know, it is what it is. I'm not going to redo the whole amp, so let's get it back in the box and do some quick sound samples, legends.